Hello, I'm Peter, this is Manish, Cyrus, Michaela, and with the rest of our colleagues, we are solving the water crisis. Our client is Dr. Bain, and he graduated from UW, from the School of Medicine, and he works with specifically internal medicines at the Dean Care Center, and he mainly works with headaches and migraines, and through Dr. Bain, we've become in contact with Ben Erker, who is stationed in Tegucigalpa, Honduras with Global Brigades, and Tegucigalpa is actually the capital of Honduras. So as we all know, water is biologically essential to all forms of life, but many families in specifically developing countries lack this natural right. And with this lack of natural right, it proves to be very detrimental to improving one's standard of living. Our proposed solution is a rooftop water reclamation blanket that has 4 main components: a blanket, conduit, filter, and faucet. Our tarp, since it's positioned on the rooftop, works with gravity to go down and meet at a point where a filter will filter our water and put it into a bucket. A few main requirements that we thought were most important were low cost, ease of use, and shippability, which our design proved to do all of them. Some previous designs, products that worked were on top you see the Gonna Wash project. That's specifically a gutter system, and on the bottom here this is a past Global Brigades project, which includes a piping system. Both of these are high cost and require a lot of infrastructure, and while these prove to be long-term solutions for communities, ours is actually intermediate. It's an intermediate step, and it's very fast acting, and it's for specific families to get clean water for everyday use.
So, in our group, we brainstormed over 100 ideas and we decided upon 5 preliminary designs in order to create a design matrix. And our 5 designs were the leaf, rooftop tarp, the clothesline, skeleton, and the lean-to designs. Our most heavily weighted factors were cost, setup, and transport. And as you can see on the matrix here, our design number 5, the lean-to design, won out with the most points at 87. And here is a sketch of our final design. It had the lowest cost, the lowest weight, it was the most shippable, and it was the easiest to set up. And here are 3 more pictures of our sticks and clay model of our design. And these are the SolidWorks designs, which give you a more clearer picture of what we were trying to accomplish. And these are some of the design materials that we decided to use. We specifically used the silver filters because we researched and found that they had antibacterial properties, which would be helpful in filtering out the water that would flow through our design. And we were also using the nylon-coated fishing wire and the pool noodles to provide structures at the edges of our tarp design.
So to begin the fabrication process, we began by cutting out our tarp to get the general shape that we wanted to come off the rooftop. As you can see, we cut these triangular portions off one of the sides, and we used those later on in the fabrication process as well. We ran into some problems along the way during fabrication. The initial fishing wire that we purchased was coated in lead, which is toxic, which is not something that you want to find in your drinking water. So we ended up having to reorder that and delay our fabrication process. But that was used to sew in the pool noodles along the straight edge sides and the diagonal sides. So then along the way we also found that our water wasn't having enough contact with the silver mesh to actually have any of those microbial properties of filtration. So we came up with a PVC design that would space out our 4 different silver filters and allow for more surface area contact. Here you can see this is a red funnel, and we needed some way to attach this to our tarp. So we drilled 16 holes along the lip of our tarp. As you can see here, we then cut 8 pie pieces out of our tarp and sewed with that new nylon-coated wire through those 16 holes. This is another view of that. Then here, before we wanted to add our wire mesh filter for large contaminants, we realized that the edges were very sharp, and we thought that with any motion, they would end up cutting our tarp, and we didn't want that. So we ended up folding over the edges before sewing it onto the top, as you can see here. Alright, here you can see we cut out 4 strips and sewed them to the underside of our tarp. This is how we connect our system to the water containment unit. And there you can see our final prototype, all in its setup, ready for shipping to Honduras. And here you can see it where we were doing some testing. And our final packaging is 15.7 pounds without the box. And our box is 4 by 2 by 1 foot.
Alright, so before we even began fabrication of our design, we did some analysis of our CAD models. For this analysis, we used a safety factor of 2, and the main things we were looking at was the stress from wind on our tarp and the pressure from how much water would be holding at full capacity. And we just wanted to make sure we were getting reasonable pressures. So we found that the max stress from wind would be 155 pascals, and the max pressure from the full capacity of its volume in water would be 500 pascals, and both of those are totally fine. And we found that using the drag force equation and just F equals mg. Now after the fabrication and during the fabrication, we ran some actual testing. The first thing we tested was the flow rate of our filter system. We sort of had to get a trade-off with our filter system. We didn't want it to be too fast because it needed to, the water needed to be in contact with the silver for enough time that its antimicrobial properties would actually take effect. But we had to get enough water through the filter that it would be helpful for family, it would be enough water for use by families, and also that you wouldn't get too much buildup. So we poured 750 milliliters of water through our filter, and we found that it took 1 minute and 41.7 seconds to get that 750 milliliters through. And doing a dimensional analysis gives us 26.7 liters per hour, which was totally fine. That's about what we wanted because a family in Honduras needs about 40 liters of water per day, and that's also slow enough for the filter to take effect. And keep in mind, this is just an order of magnitude estimate because with different pressures of water behind, it'll change how fast the flow rate is going. Next, we wanted to see how long it took to set up and what would happen during the setup of the blanket, because we wanted to make sure it was easy for families to implement. We found that setup took 22 minutes and takedown took 15 minutes, which is pretty good, I think. We found it took 3 people to set it up, which is fine because this is for families in Honduras. And then one of the key things is that you're not required to climb onto the roof to set this up, so that increases the safety of our design. You're able to do this by using the back ropes that we installed to just simply pull it over the roof. And this is also because there aren't that many solid parts in our design. Next, we tested the tensions that our tarp was going to undergo on a semi-windy day. This was about 10 to 15 miles per hour. So what we did was we staked the tarp down, and then we removed 1 stake at a time, and we replaced that with a force gauge. And we found that the tension was pretty much all the same. We have 6 different stake locations, but the tension was all the same for all of them. We found that the normal tension was about 15 pounds, and during gusts, it was about 20 pounds of tension, which is totally fine for our rope because our rope has 5,670 pounds rating. And the fishing wire has 60 pounds of rating, and that's distributed over all the different sewings you make, so that was fine. And then after we took it down, we found there was no tearing or signs of tearing. So we were happy with the tensions. And then finally, we wanted to make sure the water would actually flow into the filter when it was put on the tarp. So basically we set up the tarp and we poured water onto different spots of the tarp, and we found that wherever you poured it, it went to the funnel and it filtered through and went into the reservoir. There was no water loss over edges. There was only a bit of water loss through the corners, which we thought was fine. Finally, for marketing this, Honduras is a Spanish-speaking country, so we came up with a Spanish name. It's from 3 Spanish words: agua meaning water, manta meaning blanket, and aumentar meaning to increase or collect, so it's sort of a play on words. The prototype cost $125, but because we were ordering single parts and some of the things didn't work right, that was way more than what it actually cost to build 100 of these. Based on Alibaba estimates, it cost $18.44 per unit, which according to our associate in Honduras is a pretty good price for a product like this. Also, we made an instruction manual so that it would be easy for these people to set up. We also made an instruction manual video. if they have internet access. This is in English and Spanish, and it has some good diagrams. So in conclusion, we think our product can do a lot of good in Honduras or any country where there's a lack of water, and this is because it is low cost, low weight, and easy to set up, and also easy to transport. This is a good intermediate step because a lot of the current solutions are going to take so long to implement and they cost so much. So I think our product can do a lot of good in Honduras for families. Any questions?
Okay, so if your tarp did rip, or like if in case something like poked a hole in it, is there a way to fix it, or you have to get an entire new tarp?
I think we didn't include anything, but honestly, I think duct tape would work pretty well for that. I know it kind of sounds shoddy or whatever, but it would work fine to just patch it with duct tape.
So your tarp would be out in the open in sunlight. So over a period of time, it would absorb all the thermal energy from the sun, especially in Central America where you get a lot of sunshine. So do you think that will affect the mechanical properties of your tarp?
The tarp that we ordered, we checked, and it's rated for UV exposure. It says that it can withstand, I think it was like 20 years or something with no significant breakdown of the materials. So I thought that was fine. If that's all, thanks for listening.